Yeah. Now I will be switching over to the pyramids. The only thing what I expect from you people is, so please do the problems on hexagonal prisms. Okay, so similar type. So I covered almost four different types. Two in square prisms, two in pentagonal prisms. One of the problems on hexagon also. You take a bit angle problem or any also the uh, prisms solid prisms problems. Okay, so now I will be just moving on to the next type of solid, what we call it as a pyramids. Okay, so before I start a pyramid, so basically the pyramid is a solid which is having a base and which have a lateral faces are bounded in the form of a triangular surface. So these triangular surfaces will meet at a common point, what we call it as an apex. Okay. So I think this we discussed in the first class of the solids, the projection of solids. So we have just given introduction to the different types of solids and their terminologies. So I'm just before I start, I wanted to just refresh that things. Okay. So the axis in the case of a pyramid is the one which joins the apex to the midpoint of the base. So that is the axis. Okay. So once you say a pyramid, that solid which should come to your mind. So how you can imagine the solid that is a pyramid. So only the base. So base might be a square based, or it might be a pentagonal based, or it might be a hexagonal based. Only these three types are there in the syllabus: pentagon, hexagon, and square. Okay. So from each side we have a triangular faces, and each square triangular faces will meet at a common point, what we call it as an apex. So now such kind of solid has been placed on HP such that the axis will be always perpendicular to HP and it should be parallel to VP. And when you see such kind of solid from the front and from the top with a different position. So different position in the sense axis inclined to HP, axis inclined to VP, like that they will be going to give. So in such cases, how to draw the projection of a pyramid. So this is quite simple than that of the prisms. Okay, so prisms there are a lot of edges, lot of corners you will going to get it. So transferring it in the third position, it is a little bit of time consuming, but not in the case of a pyramids. Pyramids only a base will have 4 or 5 or 6 points. So only one point at the top, which is an apex. So it is relatively easier compared to that of the prisms. Okay. So let us start with a simple problem on a pyramid. Okay. So then we will switch on to the other problems in the other solids in the later class. So today I want to start with the one problem that is on pyramids. Okay. Yeah. So can you see this, everybody? Yeah. So take down the problem. Simple problem. I'll go to start with the pyramid. The pyramids are relatively easier. Okay. Take down the problem statement. A square pyramid. A square pyramid. 35 millimeter sides of base. A square pyramid. 35 millimeter sides of base. A 30 millimeter sides of base and 65 millimeter axis length. 65 millimeter axis length. Rests on HP. Rests on HP on one of its base edges. One of its edges of the base. I think you can take one of its edges of the base. One of its edges of the base, which is inclined to VP at 30 degrees. Which is inclined to VP at 30 degrees. the projections of the pyramid. Draw the projections of the pyramid when the axis is inclined to HP at 45 degrees. When the axis is inclined to HP at 45 degrees. So this is the problem statement. A square pyramid of 35 millimeter sides of base and 65 millimeter axis length rests on HP on one of its edges of the base, which is inclined to VP at 30 degrees. Draw the projections of the pyramid when the axis is inclined to HP at 45 degrees. So this is the problem statement. So the solid is a pyramid here. The base of the pyramid is a square base. The side is of base side is of 35 millimeter side, and the axis length is 65 millimeter, resting on HP with one of its edges of the base. This is very important because this will plays a vital role in the initial position. So edges of the base, that base edge is inclined to VP at 30 degrees. Okay, and the axis is inclined to HP at 45 degrees. And we had to draw the projection. So similar to that, how we did for the prisms. So here the solid is a pyramid. Okay. So how to go ahead? Okay, solid, a square-based pyramid resting on HP with one of the edges of the base, and that base edge is inclined to VP at 30 degrees. And this condition you can show it in the third position. Inclination of the base edge with respect to VP can be shown in the third position. And in the initial position, first rest the solid on HP with the base edge. Draw the top and front views. Second position, satisfy the condition that the axis is inclined to HP at 45 degrees. So tilt the solid such that the axis makes an angle of 45 degrees with respect to HP. In that particular position, draw the front and top views and move to the third position where we have to show the base edge, which is resting on HP, is inclined to VP at 30 degrees. In that particular position, draw the top and front. So this is how you should think in your, before you start projecting in a sheet of paper. So how I can go ahead, how I approach this problem. Okay. So let us start now. Yeah. So when you keep a solid, that is a pyramid, on HP, either it is resting on corner or resting on the edge. So when you observe that point, so generally we start always with the top view here. This is what you must follow in the case of a solid. Solids always start the projection with the top view. So in the top view, you can see the true shape and true size of the base. So whether it might be a pentagon, or it might be a hexagon, or it might be a square. So therefore, always start with the top view in the case of a solids, because solids will rest on the problems what we are going to discuss and what is there in your syllabus is the solid is resting on HP only. So therefore, always we are going to start with the top view. So in this case, when the pyramid is resting on HP, and when you observe from the top, so you should be in a position to imagine how I can see what will be the picture, what will be the image that I can see when I see that pyramid resting on HP from the top view. So simple. Okay, so basically a pyramid is a solid which is bounded by a triangular face. It has got a one base and it will be bounded with a triangular face. So therefore, so what we had in the case of a pyramid, prisms, it was the rectangular faces, because these prisms are made with the rectangular faces, whereas in the case of a pyramid, they are made with a triangular faces. So this is the difference or the change that you're supposed to bring it out when you just switch over from prisms to the pyramids. Okay. So now when you keep a pyramid, on HP and observe it from the top, okay, so you can see the true shape and true size of the base. So now the position is very important here. So what it says in the problem is the square-based pyramid is resting on HP on one of its base edges. So the solid I told you, the base edge means, of course, in the case of a square and a hexagon, not an issue. When it is resting on a base edge means you are going to get either right or left, but you have to tilt it on the towards your right only. The tilting should be always towards right. Don't tilt it towards your left. Okay. So tilt it to in the position of initial position, solid such that the base edge should be on HP. So this is the top view of a pyramid, top view of a pyramid, of a square-based pyramid resting on HP with one of the base edges. So what you have to do, how do you want to start a top view? So draw a square of 35 millimeter side such that the base edge should be, it is resting on the base edge. So first you draw the square of 35 millimeter side. Okay. Then after drawing this, what you're supposed to do is, it will have a triangular faces. So when you see that from the top, those slant edges also seen in the top view. So that is the difference between the prism and the pyramids. So in the prisms, the lateral edges are parallel. So you cannot see that in the top view. But what happens in the case of a pyramid is these edges are slant edges because it is forming a triangular face. All these lateral edges are slant edges. So this can be seen in the top view. So therefore you can notice, see here, the lines, what I have shown over here, A to C and B to D. It should be a thick line. After drawing the square in the top view, so you have to join those corners with a thick line. So because this is the triangular faces, you can see the 4 triangles over here. Okay, so these lines which meets at a point, we call it as O, the apex. Apex is represented as an O, and the corresponding point of the axis is the midpoint of the base, which is O. So in the case of a pyramid, it is easy to get the axis points because you are showing the slant edges over here. Because all these triangular faces, see, triangular face is O, A, B is the one triangular face. O, A, D is another one triangular face. O, B, C is another one triangular face. And similarly, O, C, D, that is another one triangular face. All these triangular faces are seen in the top view. So therefore, please join these triangular face edges, these slant edges with a thick continuous line. This is very, 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 very important in the case of a pyramids. Okay, so if you don't do this, or if you don't draw these slant edges with a thick line, or if you don't show these lines, thick slant edges, you will be deducted with 4 to 5 marks. Because if you don't show that, so there is no difference between the pyramid and the prism. So when you go for the prisms, there is no need for this. Only you are drawing with a very thin line. The purpose of joining those lines is to get the axis points. Okay, but here it is the edges. These edges are visible in the top view. So they corresponds to a slant edges of the pyramid. These slant edges are visible in the top view in this position. So therefore, join these slant edges from A to C and D to B. So join those corners with a thick line, and the point where these two lines will meet, that will point at the top, you will going to get the apex point, we call it as the O, and the corresponding point of the axis to the midpoint of the base is O1 point. Okay, so please be careful while you are doing a pyramid. So the slant edges should be drawn. Slant edges should be drawn with a thick line in the initial position top view. So if you don't show that, so sometimes the examiner may take it as a prism and you're going to detect the complete marks. You may lose 45 marks sometimes. Okay. So, but some examiner, if you have a concern or if you have a lenient, so he may say, so by mistake students might have done and you can give some 50% marks. So just only for drawing the lines, if you lose around 20-25 marks, is a very big loss. So therefore, please don't forget if a pyramid is there. If prism is there, not yet, but if pyramid is there, so these slant edges should be shown properly. Okay. So once you complete the top view, then we move to the front view. So just project the lines to the each point from the initial position top view to the XY line, and this similarly the axis. So first in this case the axis should be drawn because we're going to get the slant edges. So mark the axis point here, O1 dash, the point of the axis on the base, O1 dash, and from this O1 dash, measure the length of the axis. What they have given, it is 65 millimeter axis length. So from O1 dash, measure 65 millimeters, mark the point O dash. Okay, so axis length is 65 millimeters, mark the point O dash. Okay, so join this O dash and O1 dash with the axis line. Okay, now the projectors from the other edges which meets the XY line. So don't project beyond the XY line, till XY line is enough. Okay, so mark those points on the XY line where these projectors will meet. And from that point to the O dash where you have got, draw the line. So it should be the slant edges. Slant edges. This is the front view of a pyramid. Okay, where you can see the triangular face. See, when you just observe from the front in this direction, okay, you can see only this triangular face, which is OAB. OAB. This triangular face is visible for us. So this OAB is the only triangular face which is visible for us in the front view. So therefore, so O dash, A dash, and B dash. It is the only triangular face which can be seen in the front view. So that's why we have shown this as a triangle. Okay. So the remaining point D will coincides with A, where C coincides with B. So therefore, D and C is not visible, and hence in the front view we have shown D dash and C dash as the invisible points. So we have put it in the arrow. So this is the completion of the front view of a square-based pyramid resting on one of its edges of the base on HP. I hope you people are following. So please practice this. So the most important thing in the case of a pyramid is the representation of the slant edges in the top view, and also see the common mistakes I will just point out here. See, when the pyramid is there, please remember this, the front view will be a triangular face only. So please, by just mistake, if you make it as a rectangular face, so entirely 45 marks you will go to lose. So therefore, that's what I am telling you. There are so many instances, I given examples, very good students, they have about 40 out of 40 in the internal assessment marks, but they might have done the mistake of instead of a prisms, they might have a pyramid, or instead of a pyramid, they have done the prism. And they have lost 45 marks. That should not happen. So please be careful when you are attending a solid problem, read the question once, twice, thrice, until you get clarity with the problem, which is the solid they have given, how will be the front initial position and initial position top view and front view, then go ahead, please. Okay. So this is the initial position of top view and front view of a square-based pyramid resting on HP with one of its edges of the base. So now what it says in the second position, I hope you are following. So if you have any clarification, so please stop me. Please stop me. Okay. At any position, you can have your clarification of your doubts Okay, so let it be very silly doubts, not an issue, because the doubts you should not carry on this. It needs to be clarified on this. Right. Now, the second position, what we have in the second position is we have to show the axis of the pyramid is inclined to HP at 45 degrees. Axis is inclined to HP at 45 degrees. So now what you have to do is this inclination of the axis with respect to HP can be seen in the front view. Okay, now the front view, the initial position front view, we have to tilt this solid in such a way that the axis makes an angle of 45 degrees with respect to HP, and you have to tilt it in such a way that the base edge A dash and D dash should be on the XY line. So this is a mandatory requirement that needs to be satisfied. You have to tilt the solid such that either the base edge or the base corner should be on the XY line. So you cannot lift above the XY line, or you cannot lift above the HP, or in the representation of the projection, you cannot show that points above the XY line or below the XY line. So be careful. Okay. So therefore, you have to tilt the solid in such a way that the base edge A dash and D dash should be on the XY line, satisfying the condition that it is resting on HP. Okay. So therefore, how we can draw this now is, so now take a convenient distance from the initial position front view, mark the point A dash and D dash, one point on the XY line. Anywhere, take a convenient distance, mark a point which represents A dash and D dash. Now we have to construct this triangular face such that the axis makes an angle of 45 degrees with respect to HP. So how we can go about in the second position is, see, this edge which is on the XY line, which we say A dash and B dash, A dash and B dash, and the axis O dash and O1 dash, they are perpendicular to each other. Right? They are perpendicular to each other. So directly we cannot draw the axis over here. Instead of that, what we are going to do is, first we will going to draw this edge A dash and B dash, A dash and B dash, such that the axis makes 45 degrees. That we have to be satisfied. So how to do this? If this axis needs to be inclined at 45 degrees, then this edge A dash and B dash should also be inclined to HP at 45 degrees, because those two lines are perpendicular to each other. Okay, so therefore what we do here is, so once you mark the point A dash and B dash on the XY line, so take a 45 degree line clockwise, 45 degree clockwise from the XY line. Okay, then draw a line for 45 degrees. Okay, so that line represents A dash and B dash. So take a distance of A dash and B dash. So mark that point or cut that, and you can get the B dash point over here. So then this line, I'm asking you to draw the first, this line. This line is A dash and B dash from the initial position front view is inclined. You are inclining that with respect to HP at 45 degrees. So if you show that it is inclined at 45 degrees, then by default, axis is also inclined to be at 45 degrees. So this is the simple things what you should keep it in your mind. Why? Because you cannot directly draw the axis over here, and we have to satisfy A dash and D dash should also be on the XY line. So therefore, instead of drawing the axis initially, first you draw A dash and B dash on the XY line, any point on the XY line at from convenient distance from the initial position front view, mark it, and then draw a 45 degree line, because so once the axis is in 45 degree line, so this line is also inclined to 90 minus 45. Okay, the angle what it inclines, it is this is because 90, right? So this is 90 for you. This is 90. When this is inclined 45 means 90 minus 45 is also 45. Okay, so if you have the axis is inclined 40 degrees to the HP means what should be the angle this should be inclined? It is 90 minus 40, which should be 50. Okay, so be careful. Okay, so not always 45, it is 90 minus 45 in this case. So if the axis is inclined to HP at 40 degrees, if they have given, then how do you construct initially? Mark A dash and D dash over here. So what is the angle this A dash, B dash should incline? It is 90 minus 40. 40 is the axis inclination. So 90 minus 40, it should be 50 degrees. So therefore, you have to start the second position front view by drawing a line for 50 degrees. So when your line A dash and D dash is inclined 50 degrees, automatically or by default, the axis is inclined to HP at 40 degrees. So this drawing the starting with the second position front view, that angle of inclination should be equal to 90 minus the angle of inclination of the axis what they have. So first you have to draw this. Therefore, in this case, what's happening? 90 minus angle of inclination of the axis with respect to HP is 45. So 90 minus 45 is 45. So therefore, this is also inclined to HP at 45. Right? So first you draw this A dash and B dash. So once you get this line A dash and B dash, then it is easy to construct this triangle face. So take a compass, measure A dash and O dash. With A dash as center, draw an arc here, measure O dash and B dash, this edge with B dash center, cut that and join those 2 points. So transferring a triangle is not a difficult thing. Very simple by just taking the compass or by using the compass, you can just get the things done. So this is how you transfer the initial position front view to the second position. So satisfying the condition that the edge is resting on HP and the axis is inclined to HP at 45. Okay. So now the initial second position front view we have drawn. Now we have to get the second position top. The procedure remains same. So draw the vertical projectors from each point, including the axis line. Axis representation is mandatory. So excluding axis. So join those 2 lines. Join the vertical projectors from each one, and similarly draw the horizontal projectors from the initial position top view. So where it will going to meet. In this case, the number of points will be very less compared to the prisms. So A, B, C, D is the base, and O and O1 and O and 1 is the 2 axis points. So rest of things will be. So here the rules of visibility again, observing from the top. So once you mark the points for the intersection of the projectors from vertical as well as horizontal, next comes the rules of visibility. The same procedure you can see can apply over here. So the point O dash is nearer to the observer, okay, and the triangular face. See here we have a triangular face. The 2 points are there, right? B dash and C dash. C dash will be other side, so which you cannot see. So therefore we put it in the bracket over here. B dash, C dash, and O dash. That is the triangular face which can be seen or which are nearer to the observer and hence which can be seen in the top view. So the remaining point, that is the edge A dash and D dash, which is away from the observer. A dash and D dash is the away from the observer, which you cannot see in the top view. So therefore, edges which comes out of these 2 edges, these 2 points will be an invisible edge, provided if they does not form an outline. That is a very important. Okay. If the edges which arises out of these 2 points are invisible, or to represent it as an invisible, if they does not form an outline of the solid. So here, so once you mark the point, see A dash and D dash, I have shown it as an invisible line here, dotted line. So now, let's see, look at here. This is the one thing I was talking about. CD is the edge which comes out of D. D is the invisible point we take here. But here, the edge CD is an outline of a solid. So even though you will say it is not visible, it is an outline of a solid, hence it should be represented as a visible line. And representation should be as a continuous thick line. And BC is visible for you, and of course it forms an outline. AB, even though it is not visible in the top view because A is an invisible point and the edge which forms is an AB, and even though it does not seen in the top view, and it should be represented as it is forming an outline, and hence it should be shown as a continuous thick line. And AO is also not visible in the top view, but it is forming an outline. And of course, OD. The OD is also not visible because you are seeing from the top. So this triangular face is not visible for you, AOD. But OD and OA is forming an outline, hence it should be shown as a continuous thick line. And of course, the triangular face which is visible for is OCB. So it should be a continuous thick line. Okay. So only the invisible edge here is A dash and D dash. And the other edges which arises out of these 2 points, or even though they are not visible, but they are forming an outline of a solid. Hence, we are representing it as a continuous. Okay. So, of course, join the, just project it for the axis. There it is O1 and O. Axis is very important for us. So, represent it for axis. So, now we have drawn the projection of a pyramid with the condition that the axis is inclined to HP at 45 degrees. Hope you people are following. Please do it. The pyramids are relatively the simplest of all the solids. Simplest of all the solids, what we discuss. So now, moving to the third position here. So what the condition we need to satisfy in the third position is the edge, the base edge, which is resting on HP, is inclined to VP at 30 degrees. So the base edge resting is AD. AD is the base edge, and this base edge should be tilted in such a way that it makes an angle of 30 degrees with respect to VP. In the sense, the entire solid is tilted such that the edge AD makes an angle of 30 degrees with respect to VP. Okay. So for that, that can be shown in the third position. So now the second position top view should be tilted such that AD makes an angle of 30 degrees with respect to VP. So what you do, so take a convenient distance below the XY line. So draw the parallel line to XY line, and then from there you measure 30 degrees, draw a line, very thin line. Okay. So on that 30 degree line, so the base edge, that is AD, should come. It should appear on the 30 degree line. So for that, what you do, so first you can, means you are tilting in this direction. So first you can mark a point D on the 30 degree line, measure AD, that is length of AD. Okay, by using a compass or a scale, of course, it will be implemented. It is similar to that, the same as that of 35 millimeter, not an issue, but always please practice taking the distances with the compass. Always it is easy for you. So cultivate that practice. So take a compass, measure the length of AD. So now we have already marked D here with D as a center. So cut that 30 degree line with that radius equal to AD. So that arc where it cuts this 30 degree line, you mark it as a point A. So now this point, this edge, AD is an invisible in the second position top view. Therefore, join that AD with a thick dashed line. Okay. So now with this as a reference, with AB, AD as a reference here, now we have to construct the base. So I think this is square based. So it will be very simple for you. You can just draw CD which is perpendicular to DA. Take 90 degree with respect to DA. Draw CD. So measure the length, and similarly you can construct this. Or if you want to take compass, very simple. So measure, take a radius of CD and CB, BD, so CD and BD. With D as a center, cut a knot. With this as a center. Similarly with A and this, cut here. So opposite way, you can just get it and you can get the. So now we construct this square. We can with reference to the edge AD. Okay. So now once you get this AD, then you have to mark the point. What is the length of this O? Okay, O should be drawn. So how do you measure this? So take a convenient distance from this. Measure this. Okay. So what is this distance from O1 and O? Yeah. So now you can connect the points, join the points and measure O. Now we have to mark the point O with reference to the O1 and you have to join these. So once you transfer this complete pyramid over here, okay, then project it back to get the front view. So project the top view to get the front view over here. So draw the projector lines from each one. So again, similarly, you draw the horizontal projectors from the second position front view, and then you mark the points first. So once you mark the points, then you are going to get what is the front view. So the intersection points you can mark, and now you apply the rules of visibility. When you are just observing this solid from the front, the observer is here, okay? So the base edge is completely visible for you. Sorry, base is completely visible for you. So the base of a pyramid is nearer to the observer, and hence base is completely visible. So once the base is visible, so then the point which is away from you is the point D, the furthest point from the observer in this front view. So the edge which comes out of D should be considered as an invisible edge and should be shown as an invisible edge in the front view if it is not an outline of a solid. Okay. Now, so once you draw this point D, okay, so base is completely visible in the front. So you can make this base is the continuous decline over here, right? And then we can see this complete triangular face OBC. OBC is visible, and of course OAB is also visible in the front view. So only the triangular face which is not visible is the one which comes out of D. So this is the D dash. So because O dash and D dash is the edge which is invisible. It is invisible in the front view. So that you can mark it as an invisible edge and join all this, they will form an outline, and then join O dash and O1 dash, which is an axis line. Okay. So this will be how you will go into complete the projection of pyramids. Okay. So if you have any doubts here, ultimately you are satisfying the base edge A dash and D dash on the HP. So this is AD is resting on HP. So this is how you are going to validate that A dash and D dash should be on the XY line. Okay, so this is how you should represent it. So please follow this. Please. So if you have any question anywhere, so please talk to us because this is very important. Yeah. Any doubts, my dear students? You can talk to me. If you have any clarification, unmute your microphones. Yeah. Anybody has having any doubts, you can talk to me before just we wind up the class. My dear students, please keep on doing your sketchbooks and your sheet of paper, whatever you are having available with you. Please complete all these drawings in your sketchbooks. So why? Because you will have very short periods before your exams will start. So the time gap is very short for you. Once you come to the college, maybe within 3 weeks or 4 weeks, you will be having examinations. So a lot of things to be happening in those 2, 3, 4 weeks. So better always complete and get ready with your sketchbooks and everything. Okay, so you have to attend the tests also. We have to conduct 2 tests in CAD, engineering graphics and EGDL. And a lot of things happening. It's difficult for the people. So therefore, please keep everything ready. Okay. Once you come to the college, we may ask you to submit your sketchbooks. So at that time, you cannot say because we have to give the marks for 40 marks. 40 marks we cannot easily we cannot give. So you have to complete this. So keep it ready. Everything you keep it ready. So once we start, once the class starts, we will go into just discuss it in a very brief way and just go into. Yeah, any students, any clarification before I just wind up? If you have any, if you don't have any clarification, I will just stop this now.
No, sir, no doubt.
Okay, okay then. We will just meet in the next class. So please complete your sketchbooks. Okay. Thank you very much.